Okay, that was strange. Don't know what happened then. Okay, so what have we got? So we've got camping charges for a campsite. And we've got Rodri and Lars are planning a camping holiday staying at Maes Allen Camping. They're going to take only one tent between them, take a tent covering a rectangular ground area measuring 2.5 by 4.4 metres. They're both going to stay for a total of 12 nights. Their holiday is just 8 weeks away, and they each plan to save £15 per week from now until their holiday in 8 weeks' time. Will the amount they save be enough to pay for their holiday? That's the question. That's what we have to answer. Okay? And there's a lot of information to work with in order to go about answering that. So let's take a look at what information that we've got. They're only taking one tent between them, and the tent that they are taking is covering a rectangular area with 2.5 by 4.4. Now, a diagram may help you, it may not. But I know that once I've drawn it like that, to work out its area, I multiply the length by the width. Okay? So the area will be 4.4 times 2.5. Now this is a non-calculator paper. So you've got to have a non-calculator skill to multiply those together. All right? Now I know that the one that most students are comfortable with is the Chinese multiplication method. So I'll do it that way. But if you've got a different method you're happy with, then that's absolutely fine. So to do 4.4 times 2.5, we'll just deal with the digits first of all. 4 times 2 is 8. 4 times 5 is 20. 4 2s are 8. 4 5s are 20. And then we add up the diagonals. So I have a 0, 8 and 2 is 10, 0 down, carry 1, 8 and 2 is 10, and 1 is 11. So you end up with $11,000 from your multiplication. And then we worry about where the decimal point goes. Well, different ways of doing this. You can count the number of digits after the decimal point. So there's 2, so there'd be 2 digits after the decimal point there. Or you could just estimate, that's 4, that's 3, 4 3s are 12, so the decimal point is going there. So the area of their tent is 11 square meters, not centimeters. So that's a consistent unit. That's the right unit for area for those measurements. So their tent covers an area of 11 square meters. And the costings mean that if the area is less than 12 square meters, it's going to cost £14 a night. I'm going to use that, so I'm going to highlight that, and then so the cost per night of tent will be £14. Okay, so that's your language for what that is. So the total cost for the tent will be £14 times the number of nights they are staying. Okay, so it's going to be £14 a night, and they are staying for a total of 12 nights. But there's an offer. They stay 5 nights and get the next night completely free. This means no charge for tents or people on every 6th night. So although they're staying for 12, they only pay for 10. So that's why it's 14 times 10, which is £140. Coming back to the information. They're also charged £4 a night per person. So the cost of this will be 4 times 10 times 2. £4, 10 nights, 2 of them. 4 tens are 40 times 2 is £80. Okay, so the total that they have to pay is going to be the 140 quid for the tent and 80 quid for each of them. So the total cost of the holiday will be 140 plus 80, £220. Now, have I answered the question? Let me go back. Will the amount they save be enough to pay for their holiday? Total cost of the holiday. I haven't answered the question. Okay, so I got to go back now to think, well, what else do I know that'll help me answer the question, will the amount they save? Saving, where's that? Here. They each plan to save £15 a week from now until their holiday in 8 weeks' time. So their savings come to £15 each in 8 weeks. 15 times 2 is 30, times 8, 3 8s are 24. They save £240. Back to the question, will the amount they save be enough to pay for their holidays? Well, the total cost of the holiday is £220. The savings come to £240. So to answer the question, I'm going to say, so yes, they have enough saved. In fact, they got £20 more than they need. All right? So, if I look at how that is marked, there are 2 marks for working out the area. So, a method for showing 4.4 times 2.5 and an answer for seeing 11. So you've got 2 marks, even if you can't do anything else, but you think, oh, I can work out an area of a rectangle, you're earning marks. The next 2 marks are for working out, doing the maths to get that 220. So the fact that there are 2 of them, the cost per tent. So you've got 2 marks for the methods of coming up with 220 and an answer mark for that. And then a method and an answer for the savings, which you could have worked out before, it doesn't matter what order, and then the final explanation mark for answering the question. Will they have enough? Yes, they will have enough. And then the OCW question marks, where you get an additional 2, are for each line of maths that you were saying. Area is that. Total cost is that. Total cost is that. So by setting out what each line of maths is doing, and the second mark is for consistent units. So when I'm talking about area, I'm in meters squared. When I'm talking about money, I'm using pounds. And that will get you those marks, even if you get the answers wrong. Question 4. Lazar wants to send a package to Germany. He looks at the pricing charts for 3 different companies: Parcel Max, Direct Go and Pack to Save. Parcel max, total cost is the sum of the three dimensions in centimetres times 0.60 pounds. Total cost for direct go is based on the volume, and pack to save is the total area of all the 6 faces. Lazar's parcel is a cuboid measuring 10 centimetres by 20 centimetres by 30 centimetres. Find the cost of sending the parcel for each of the 3 different companies. That's the question. That's what you've got to do. So first up, parcel max. So for parcel max, I need the sum of the 3 dimensions times 0.60. Now, on a calculator paper, you'd be happy working with 0.60 pounds. But on a non-calculator paper, I would be suggesting you write that as 60p. I suggest you would write that as 1p and that as 2p, and then worry about changing it to pounds afterwards. So for parcel max, that the word sum in maths means add them together. Okay? Sum means add. So in order to work out the total cost, I need to add the 20, the 30 and the 10 together, which is 30, 40, 60. And we're going to times that by 60p. 6 6s are 36, followed by 2 zeros. That would be the value in pence. So 3600 in pence. To turn into pounds, you would divide by 100. So the decimal point would end up there. So parcel max is going to cost £36. Direct go is the volume. You need to know that the volume is length times width times height. We didn't put that on the front sheet, we could have. So the volume will be 20 times 30 times 10. 2 times 3 is 6, times 1 is 6, and 3 zeros. So that will come to 6,000 centimetres cubed, which we've then got to times by 1 pence. Which is 6,000. Pence, which in pounds, divided by 100, would be £60. Okay? And then finally we got pack to save, and for pack to save we need the total area of all 6 faces. So the area of the front is going to be 20 times 30. So I'm going to have front 20 times 30, which is 600. And I've got a front and a back that'll be the same. So front and back will also be 600. Then I've got the bottom will be 30 times 10, which will be 300, and the bottom and the top will be the same. And then I've got a left and a right. The left will be 20 times 10 rectangle, which is 200, and the right will be the same. So I need the total area of all 6 faces, so I got to add those together. So I got 6, 12, 15, 18, 20, 22. So I've got 2,200 centimetres squared, and then I've got to multiply that by 2 pence. which would be 4,400 pence, or £44. Okay, so have I answered the question? Find the cost of sending the parcel for each of the 3 different companies. Parcel Max £36, Direct Go 60, Pack to Save 44. Yes, I've answered the question. Great. Let's go on to part B. What is the percentage saving that Lazar will make by choosing the cheapest option rather than the most expensive option? So this is a percentage that you would need to know how to find. Percentage change is, well, first of all, let's list the most and least. So most expensive is £60. The least expensive is £36. The difference between the two will be £24. So the maths that you would have to do here, and if you haven't learnt this, you'd struggle to remember it, is it's the change divided by the original, or the highest quantity, or whatever it is, times 100. So for us, we'd be doing 24 compared to the most expensive times 100. £24 times 100 is 2400 divided by 60. We can divide top and bottom by 10 because we've got the 0. So we're actually left with 6 into 240. 6 goes into 24 4 times. So that works out to be 40%. That's quite a tricky percentage question. Okay? So how is that question marked? You've got, for these ones, quite straightforward, a method mark for adding them up and multiplying by 60, and an answer mark. For this one, there's a method mark for finding out the volume, then a method mark for the cost, and your answer mark. So there's 2 methods there. And then for part 3, there's 2 method marks available for working out the total surface area, and an answer, and then a final answer for your £44. And for this, there's a method mark for this part of it and an answer mark for that. So I would say part B there is quite tricky at the intermediate tier. Question 5. Jasmine entered herself, Sophie and Bryn as a group in a talent contest. Bryn only had a minor part. Bryn, Sophie and Jasmine won the contest. They shared the prize money in the ratio 2 to 6 to 7, with Bryn getting the smaller share. Jasmine won 560, the largest share. Question: how much did Bryn and Sophie win? So I'm seeing a ratio. So when I see a ratio, we tend to keep things in the order that they're given. So Bryn, Sophie, Jasmine, BSJ, shared the ratio 2 to 6 to 7. Bryn gets the smaller share, and Jasmine won £560, which is the largest share. So where you have to be careful with ratio is it isn't always a question of adding them up to find the number of parts and then dividing and finding out each part. This isn't that type of question. They're giving you a corresponding pair of values in the ratio. So what you have to do with this question is find out what you multiply by to take you from the ratio value to the given value. It's paper 1, so it's not going to be horrible numbers. It's your 7 times table again. 7 goes into 56 8 times, so you're actually multiplying by 80. Now if you're multiplying that by 80, you have to do the others by 80 as well. So that's going to be 6 times 80, 6 8s are 48, and 2 times 80 is 160. So how much money did Bryn receive? £160. How much did Sophie receive? £480. Jasmine gave 15% of her winnings to charity. How much did Jasmine have left? There's the question. Okay, it's a non-calculator paper, so I know how to find 10%. Jasmine's winnings were £560. So 10% of that, we divide by 10 to get £56. 5% would be half of that again. Half of 56 is 28. I want 15%, which means I need to add those together. So I'm adding the 56 and the 28 to get £84. I go back to the question. Have I answered that? How much did Jasmine have left? Did she have £84 left? No, that's what she gave away. So she's got 560 less £84. Okay, non-calculator paper, however, whatever method you use to work that out, I need to borrow from that to get 6, and then I need to borrow from that to make 15, which is 7. So she's got £76 if I've done my subtraction correct. 476 even. So £476 left. Okay? The talent contest is held once a year. Every year the cost of putting on the talent contest increases by 10% of the previous year's cost. In summer 2014, the cost was £6,600. Calculate the cost of putting on the summer 2017 talent contest. So in 2014, it cost £6,600. It then increases by 10%. So 10% of that will be £660, divide by 10. So in 2015, the cost is going to be £660 plus, £6,600 plus an additional 660. Okay, and it's non-calculator paper, so if you want to do that in columns, that comes to £7,260. So that's how much it's going to cost in 2015. Does that answer the question? No, I want 2017. So I've got to go another year. In 2016, it's going to be 7,260 plus 10% of that, we divide by 10, will be £726. Let's work that out. 7260 plus 726. 7986. Does that answer the question? No, because I need to go one more year. 7986. 10% of that, I'm going to divide it by 10, means that the decimal point is going to end up between the 8 and the 6. So that's going to be £798.60. So I've got to do 7986 plus £798.60. I'm not sure what's freezing it. Is it? Oh, great. So £8,784.60. Is that the cost at summer 2017? Yes, it is. So that's my final answer. £8,784.60. So it's a fair bit of work, but it's only finding 10% and adding on. So with that one, question 5A, there's 1 mark for seeing 80. So just seeing the 80 is worth 1 mark. And then there's a method mark for then finding out, multiplying the others by 80, and 2 answer marks for each of the given answer. And then for part B, there's a method mark for how you work out your £84, and an answer mark for your actual answer of 476. And then in part B, we've got 1 mark for the first addition of 10%. So there's a B mark for that, and then there's a method mark for adding that on to take you to the next part, and then a final method mark for your final answer. So there's quite a lot of maths there for 3 marks. Question 6. A survey was carried out to find how much time a group of 16-year-old students and a group of 18-year-old students spent using social media. The frequency polygons below, which use equal time intervals, illustrate the results. So this graph is showing me 16-year-old students, and a frequency polygon is similar to a bar chart, except rather than drawing bars like this, okay, which would be a grouped frequency diagram showing the same information, it just plots the points on the middle value. So that is actually saying that 40 students were on social media for between 5 and 15 minutes. It's telling you 60 students were on social media for between 15 and 25. 40 students were between 25 and 35. Then we have 70 students there, and here we've got 20 students. Same with the bottom one? Yeah. Write them on. Yeah, you can write whatever you want on to help you. So with this one, it's going to be 20 students represented there, 20 represented there, 60 there, 70 there, 60 there. Okay, so that's the information from the graph that they're giving you. Now, what are they going to ask us to do with it? Haven't asked us any questions yet. So the first question, straightforward, isn't embedded, you don't need to highlight it really. How many 16-year-old students took part in the survey? So coming back to the 16-year-old graph, I've got 40 students in that first part, then I've got 60, then I've got 40, then I've got 70, then I've got 20. So I need to add all those together. 100, 170, 180, 190, and 40, 230. So that's that one. How many more 16-year-old students, and that's the key word there, more. How many more 16-year-old students than 18-year-olds spent between 15 and 25? So between 15 and 25 16-year-olds is this group here, which is 60. So 16-year-olds, 60 students. And then if we look at the 18-year-old students, between 15 and 25, there are 20. The question's asking how many more, so it's the difference between it. Wesley says the 16-year-old students generally spent about the same time using social media as the 18-year-old students. Using the frequency polygons, how would you explain to Wesley, so there's the question, that his statement is not true? So he's saying 16-year-old students generally spent about the same time using social media as the 18-year-olds. Now it's usually easier to work with this once you put the numbers on the graph. So if we look at the half-hour mark here, the number of 16-year-olds spending more than 30 minutes would be, or 30 minutes and more, would be 40 plus 70 plus 20. (130) of them are spending over half an hour. For the 18-year-olds, that same part of the graph is showing 60, add 70, add 60. So that's 190 of them. So the graph is actually showing that these have got a lot more 18-year-olds spending more than half an hour on their graphs. But you can write it anywhere. Okay, so don't worry, the examiner will see what you've put on the graphs. So how would you explain to Wesley that it's not true? So we're going to say something like, because the number of 16-year-olds spending at least 30 min equals 130 compared, and that's really important, that word there, compared, because that's showing that you're using both graphs. So compared to 190 18-year-olds. Okay, so there's a big difference between the two, and that's what you have to do, is use your graphs to show that information. Marks, well, there's one for each of those. So they're not huge mark earners, but if you draw on the graphs, it does make it a little bit easier to see. Question 7. Carrie is making a jigsaw puzzle. She's designed the pattern on a piece of paper. Carrie plans to make each piece of the jigsaw a different colour. Part of her plan is shown below. Okay, so you've got a massive lines and angles and measurements. Carrie now sketches a diagram of the red piece of the jigsaw, which is shown below. She shows some extended lines and indicates all the angles she needs to find. Okay, no question yet. Find the 4 missing angles in the red piece of jigsaw. Okay, let's deal with that first. Really important piece of information there. Diagram not drawn to scale. That means I can't use that to measure them. Okay? So that's out of the question as far as working out what those angles are. But on those diagrams, we've got these little things here, which are crucial, because those are triggering parallel lines. Parallel lines means I've got some angle properties that I know. Generally, if they give you an A, B, C, D, the easiest angle to find is A, then B, then C, then D. Not always, but as a rule that would be the case. So the easiest one to find there would be angle A. So with angle A, I'm looking and I'm seeing I've got two straight lines that intersect. So the knowledge that that's pulling is opposite angles in intersecting lines are the same. So if that one there is 72, A is also 72. Now I would say that would help if I wrote it on the diagram. I'm going to move it onto my answers, but the examiners will be trained to look at the diagram. So as long as you've written it there, you're in business. Now, angles on parallel lines. I've got parallel line here, and I've got this line intersecting. The two key properties in parallel lines are what we call Z angles, which are alternate angles, and a Z angle there would be there, where I'm taking across from there down to there and back again. That angle B is actually the same as that angle that side of it. That's alternate angles, or Z angles. The other one is corresponding angles. The two angles inside that parallel pair there have to add up to 180 degrees. So if that's 72, I know that that must be 108 so that they add up to 72. So B is 108. Then I come to this side. In order to work out C, I can tell that it lies on a straight line. So that angle and that angle have to add up to 180. So angle C is going to be 94 degrees in order to make those two add up to 180. So C is, what did I say, 94. So C is 94 degrees, and then D, that and that have to add up to 180, or it's an inverted sort of F angle, 86 and D are the same. So those are the four angles, not measured, using properties of intersecting lines, straight lines, and parallel lines. Okay, so I've done that. Then it says, draw the red piece of Carrie's jigsaw accurately. One side has been drawn for you. So this is now where you are going to need, in order to draw that, now you need that, and you also need a ruler. So let's figure out what we need to do here. If I start with that 72 degree angle, I need to put the center of my measurer at the end of the line where I want to draw the angle. And I need to line the 0 along the line that the angle is being created from. So that's going to look like that. The next thing you have to do, which often makes this tricky, is work out which scale you are going to use, because you've got an inside scale and an outside scale. Now I want to draw 72 degrees, which is, it's going to look about that size. It's going to look acute. So I'm going to go along the outside scale, 0, 10, 20, 30, up to 70, 72 degrees, and I'm going to make a mark, and then I'm going to draw that line, and for now I'm just going to draw it up the page. I don't know yet how long that has to be. It's going to be 6 centimeters, so I can mark that on, line my ruler up 0 and go up to 6 and make a mark there. So that is where that corner is going to be. So now I've got to draw a 108 degree angle from that point there. So I'm going to move my measurer to that point, and now the 0 is going to come in that direction there. So the 0 needs to line up here. So I'm going to turn it around, line the 0 up there, and the angle comes that way around. So 108 is the outside scale again. There's 100, 105, 108. And I just extend that line because it doesn't give me the measurement of that line. I don't know how long that distance is. So in order to work out where that corner is going to be, I now need to come back to this end of my shape and measure angle D, which is 86. So center of my measurer at this end, I need to line the 0 up with the line that exists, and I need to measure 86 degrees, and this time the scale is on the inside to 86. There's 80, there's 86. So that's the accurate drawing. That is 72 degrees. That's 108. That one is D 86. And this one is 94. The marks for that, there are 3 marks for getting the angles right up here, and then there are 3 marks for the accurate drawing. Now, if you've got some angles wrong and you've correctly drawn it for your wrong angles, you could still get those marks for the angles that you've measured. Okay? Okay, we're going to move on. You know, you'll take this paper home with you. If you haven't quite finished that, you can have a play at home. Question 8. Bethan builds a rectangular sheep pen. Perimeter fence of the sheep pen is 18 meters long. It costs her £1.10 for every 0.5 meters of fencing used to make the sheep pen. Question: calculate the cost of the fencing used to make this sheep pen. How much is it going to cost? Well, it's going to cost her £1.10 for every 0.5 meters. So that's information that we can use. I don't like working in 0.5 meters. I'd rather work in meters. So if it's £1.10 for every half meter, it's going to cost £2.20 for every meter. That makes more sense to me. And I've got 18 meters. It's going to work out at 18 lots of £2.20. We're on a non-calculator paper, so we've got to be able to deal with 18 times 2.2. So I'm going to go back to my Chinese method. What's back? Really weird. Don't know why it's doing that. So 18 lots of 2.2 is 16, 16, 0, 2, 0, 2. Add up your diagonals. 6, 9, 3, 0. So 396. Check I've done that right. 6. Yeah. So that's 396. Now 18 lots of 2. So if it was 18 lots of £2, it would be £36. So that, putting the decimal point in the right place, is going to be £39.60. The length of Bethan's sheep pen is 2 times its width. Find the length and width of this sheep pen. You must show you're working. So we can't do this by trial and error. A little diagram will help. The length is 2 times the width. So if the width is W, the length is going to be 2 times that, 2W. And because it's a rectangle, that means that's W, and that's 2W. And I know, coming back up here, the perimeter is 18 meters. So those have got to add up to 18. So I've got a W, a 2W, a W, and a 2W that have to add up to 18. How many W's have I got? 1, 2, 3, 4, 5, 6. 6 W's come to 18. So we've been doing lots of maths practice for solving equations. To get the W on its own, I have to undo a times 6 by doing the opposite of timesing 6, which is dividing by 6. So W equals 3. W is the width. The length is double it. Part B. Bethan decides to build a new sheep pen. The perimeter fence of the new sheep pen is 16 meters long. The length is 3 meters longer than the width. What do they want me to do? Form an equation and solve it. I'm going to go back to another diagram. What do I know this time? I know that the distance all the way around is 16. So when I add them together, it's going to come to 16. This time though, the length is 3 meters longer than the width. So if my width is W, 3 meters longer, now it isn't 3W. 3W is 3 times as long. 3 meters longer will be that. So this time, when we form an equation, we've got W, and W plus 3, and W plus 3, and they've all got to add up to 16. 1, 2, 3, 4W plus 6 equals 16. I get rid of the add 6 by subtracting 6. So I get 4W is 10. W will be 10 divided by 4. Half of 10 is 5. Half again, 2.5. So the width this time is 2.5 meters. The length will be 3 meters longer, which will be 5.5 meters. Okay, so how is that marked? There's a method for how you work that out and an answer. For this one, we're just looking, however you find them, to get your 6 and your 3. And then for part C or part B, there's a method for forming your equation. There's a method, so long as you get it down to that point there, it's worth 2 marks. And then finally, for getting the pair of answers, the length and the width. Question 9. So this is the last question on the foundation tier. Okay. Ollie and Joseph both have jobs in a workshop that make decorations. They make decorations using small squares of stained glass. Ollie has made the following decorations. He labels the first decoration D1. He labels the next 3 in order, D2, D3, D4. He continues to make decorations and labels following this pattern. After making decoration 5, he notices he has only 10 small squares of stained glass left. How many more squares of stained glass will he need? So there's the question. How many more? Well, let's take a look at what pattern is developing here. So D1 has got 1 square. D2 has got 3. D4 has got 3, 6. Sorry, that's D3. And D4 has got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So with any pattern, we look at the differences. What's happening? What's changing every time? That's gone up by 2. That's gone up by 3. That's gone up by 4. So every time it's going up by another 1. So to work out D5, I know I'm going to add on 5. So D5 has 15 squares in it. D6 will go up by 6, so we'll have 21 in it. What's the question? How many more squares of stained glass will Ollie need to make decoration D6? So he needs 26. Sorry, 21. He needs 21, and he's got 10 already, so he's going to need 11 more. Ollie uses a rule to work out how many squares he needs for each decoration. He states that to make decoration D10, he would need 55 squares. Is Ollie correct? So if we look at what pattern's happening here, to get to D6, we're doing 1 plus 2 plus 3 plus 4 plus 5 plus 6. To get to D7, we'll be doing 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. So to get to D10, you're going to be doing 1 plus 2, 3, 4, 5, 6, 7, 8, 9, 10. Adding them all together. When you add those all together, what you're doing is 10 and 1 is 11, 9 and 2 is 11. It's basically 5 lots of 11, which comes to 55. Question is he correct? Answer is yes, he is. He really likes making these patterns. So he's made the following 3 decorations using small squares of stained glass. He labels these P1, P2, P3 in order. Joseph continues to make decorations following the pattern he has started. P1, 1, 2, 3. P2, 1, 2, 3, 4, 5. P3, 1, 2, 3, 4, 5, 6, 7. We're looking for a pattern. This time, the pattern's the same. That means we've got an nth term rule we can get. Okay, so we would, in GCSE maths, we'd have an nth term rule there. It would be a 2n rule because it's going up in 2s, but the first term isn't 2, it's 3, so we've got to add 1 to it. So the rule that's happening, we couldn't get an nth term rule for these ones because they weren't going up in the same number. This time they are. So it's a 2n plus 1 rule. Pattern 22 and pattern 18 is what we need to work with. So P18 will be, instead of n, 18. 36 plus 1, 37 squares. Pattern 22 will be 2 lots of 22. Add 1, which is 45 squares. So how many more? Eight more. So because they were going up by a constant number, I could immediately find that nth term rule. Joseph says, sorry, no he doesn't. Joseph has 22 squares. He says, I think I can make one complete decoration using all 22 squares with none left over. Is he correct? Well, if you look at the numbers, they're all odd numbers. And they're all odd numbers because we're adding 1 to what will always be an even number. So, is he correct? No. Give a reason. All numbers in the pattern are odd. 22 is even. And then the final little bit for question 9. Each small square of stained glass measures 1/2 centimetre by 1/2 centimetre. The perimeter of one of Joseph's decorations is 10. Complete the label that Joseph would use for this decoration. So again, we're looking for a pattern. Okay? Now, when we're working with perimeter, if that's 1/2 and that's 1/2, 2 of those is going to be 1 centimetre. So that's 1 centimetre, that's 1 centimetre, that's 1 centimetre, and that's 1 centimetre. So for pattern number 1, the perimeter is 1, 2, 3, 4 centimetres. For pattern number 2, 1, 2, 3, 4, 5, 6 groups of 2. Pattern number 3, 1, 2, 3, 4, 5, 6, 7, 8. So I can see this time they're going up 4, 6, 8. So pattern number 4 would have a perimeter of 10. So what's the question? Complete the label that Joseph would use for this decoration. It would be P4. Okay, that takes us to question 9, okay, which is the last question that's also on the foundation tier. Okay, so for those of you that are doing the intermediate, it's well worth sticking around for the remaining 3 questions. But for those of you that are doing the foundation tier, numeracy paper, you won't be asked the next questions. All right, we'll crack on. Cambria Airlines has planes that carry up to 70 passengers. For safety, the crew practice the emergency exit procedures with a group of 70 passengers. Every 10 seconds, the safety officer records the total number of passengers who have left the plane. He's displayed the results in the cumulative frequency diagram below. That triggers a grade B topic in your brain, okay? It's a very specific thing that we practiced in the autumn and we've gone back to in the last week. It's all to do with interquartile ranges and medians. Estimate the median time taken by the passengers to leave the plane. So this is telling me that the graph represents 70 passengers. The median is going to be in the middle, so it's going to be 35 passengers. So this axis is telling me the number of people. This is telling me about the time it takes them to exit the plane. So when I'm looking for 35 passengers, I'm going up the graph to 35. I'm marking on the graph and reading down. And to show the examiner I'm trying to do the right thing, I'm going to actually write that on the graph. So I go to 35 because there are 70 passengers, across to the graph and read down, and the answer is 45 seconds. Part B. How many passengers took more than 50 seconds to leave the plane? So there's the question. The time is along the bottom axis. So 50 seconds is going to be there. So this time I'm going to be reading in the opposite direction, because I'm not talking about people, I'm talking about time. And that's giving me an answer of 40. But one of the things, the learning parts of cumulative frequency that you need to know is that when you read off a cumulative frequency, it actually tells you the less than value. So when you read off the 50, that's actually saying that 40 people took less than 50 seconds. The question is asking for more than 50 seconds. So 40 took less. The more than is this distance here. So it's the gap between 40 and 60, which is actually 30 people. Took more than 50 seconds to leave. Okay, so when you're revising cumulative frequency, that's a key learning part, that what you're reading off is less than, not more than. Cambia Airlines has a policy that states the following. In the event of an emergency exit procedure, at least 90% of the 70 passengers must have left the plane within 1 minute. What's the question? Did the practice exit procedure meet the requirements of the airline's policy? Okay, so I've got a minute and I've got a graph. So what am I going to get out of that information? Well, I know that a minute is 60 seconds, so I can find out from the graph how many passengers left within that minute by going up to 60 and reading across to getting 65. So from the graph, I know that 65 passengers left in under a minute. So 65 passengers exit within 1 minute. Now, I still need to decide, does that satisfy the procedure of at least 90% of 70 passengers? So 90% of 70 passengers, well, 10% is 7. So 90% will be 9 lots of 7 equals 63. So they need 63 to leave. The graph is saying 65 left. So did the practice emergency exit meet the requirements? Yes, it did. They needed 63, they got 65. That's back. So the marks for that, 1 mark for the 45 seconds, 1 mark for that, and then for part C, there's 2 marks just for finding 90% of 70, so you didn't even have to go near the graph to get those 2 marks. There's 1 mark for reading off the graph the 65 passengers, and 1 mark for a correct conclusion. Okay, another favourite B grade question on these paper 1 numeracy questions are box and whisker plots. I think most of us have practiced these in the last couple of days, a couple of lessons. They basically give you the similar information to cumulative frequency. We're talking about medians, interquartile ranges and ranges. So the following box and whisker plot shows the flow of water through a drain measured in cubic meters per second. The flow of water was measured at 11 a.m. each day for the first 5 months of the year. In which of the 5 months was the median flow of water the greatest? So you need to revise box and whisker plots in order to be able to access this question. But if you do, then there's quite easy marks to pick out of them. So in which of the 5 months was the median flow of water the greatest? In a box and whisker plot, the median is the line that's inside the box part. So that's a median, that's a median, that's a median, that is, and that is. And I want to know where that median is the greatest. So where is it furthest up the graph? It's furthest up the graph in April. Then it asks us, in which of the 5 months was the range of the flow the greatest? The range is all to do with the whiskers, not the box. So the range, that's the minimum value of flow measured. That's the maximum value. Minimum value, maximum, min, max, min, max, min, max. So the range is the box and whisker which has got the biggest gap between the minimum and maximum value. So just by looking at it, we can see that January has that greatest gap. Iona is writing some statements for a report on the flow of water through the drain. Complete each of the statements below. That's what they want you to do. Both the upper quartiles and medians in the months of blank and blank were the same. Well, I've already said to you what the medians are. The upper quartiles are the highest end of the box. So you could have figured that out by guessing, as long as you knew what the medians were, because there are no other boxes where the medians are the same. But for January and February, we got the medians and the upper quartiles the same. "25% of the results in March show the flow of water was greater than blank." What these box plots do is divide all the data into quarters. A quarter of the data for January is in that region. There's a quarter in that region, a quarter in there, and the biggest quarter is in that part. So if we look at March, The highest 25% in March is this part there. So that 25% is bigger than whatever that reading there is. And that reading there is 4123. 43 cubic meters. Then we're into a true or false. 25% of the results in January show the flow of water was less than 6. So 25% least is in this area, which isn't less than 6. Nothing was measured less than 6. So that one is false. The units M3/S measure the volume of water passing through the drains. Well, M3, meters cubed, is volume per second. Volume per second is true. The mean flow of water in April was certainly greater than 36. Well, if we look at April, 36 is there. But a box plot doesn't give you mean, it gives you median. It's a different average. So we can't be sure that it's certainly, it might be, but we can't tell from the data we've got. So that is false. And the month with the greatest difference between lower quartile and median was May. So the lower quartile is the bottom of the box, the median is the middle, so we're looking for the biggest gap between the bottom of the box and the median line in the box. And that's certainly not May, that's actually the smallest gap. So that is false. So we've got false, true, false, false. And then we're on to the final question, you'll be delighted to know, and it's quite possibly the most hideous question that you could get on a non-calculated paper because it's standard form. Okay? So if you haven't been taught standard form, this isn't going to mean anything to you at all. If you haven't done it for a long time, it's going to be a challenge. But we'll go through it anyway. A standard piece of A4 paper is usually 0.08 millimeters thick. What is 0.08 millimeters written in meters in standard form? You need to know there are 1,000 millimeters in a meter. Milli is Latin for 1,000, I think. So there's 1,000 millimeters in 1 meter. So that is a really, really small, can be an even smaller number in meters. We need to divide it by 1,000. Okay? Now the way you've probably discovered, if you've done standard form, to do this is if we're going to divide that by 1,000, we're going to actually move the point 3 spaces. So by dividing by 1,000, we're jumping 3 times, and then we need to fill in the gaps with zeros. So that becomes, in meters, 0.000 1, 2, 3, 4, 8 meters. And if that's not enough work, they then want it in standard form. In standard form, you need the number to be between, the number part of it, between 1 and 10. Means I'm going to move that decimal point once, twice, 3 times, 4 times, 5 times to get 8 times, and then the number of jumps gives you the power, but because it's a small number, it becomes a negative power. So the actual value in standard form is 8 times 10 to the power of negative 5. Okay, if you haven't done standard form, I wouldn't lose sleep over this question. This is by far there for the overlap with the higher tier. Part B. A piece of card is 1 millimeters thick. A stack of these pieces is 3 times 10 to the minus 2 meters high. How many pieces of card are there in the stack? So 1 millimeter, there's 1,000 millimeters, sorry, what am I doing here? I'm taking that into meters, so there's a so that's going to be 0.1 centimeters, which is going to be 0.001 meters. That in standard form, 1, 2, 3, 1 times 10 to the minus 3. So each card is 1 times 10 to the minus 3 meters thick. And I want to see how many of those fit into this stack of card. So I then want to do 3 times 10 to the minus 2 divided by 1 times 10 to the minus 3. When you do that without a calculator, you can do the number part, so 3 divided by 1 is 3. And using powers of indices, which you probably haven't done either, when you're dividing bases that are the same, you can subtract their powers. So you end up with negative 2 take away negative 3, which means it's negative 2 plus 3, which is 3 times 10 to the power of 1, which is 30. So there are actually 30 pieces of card. What assumption have I made? Well, I'm assuming that there are no gaps. They all fit in exactly. Horrible question. Horrible. And there's more. So this is the very, very last bit now. In 2012, it was recorded that the total mass of the paper used for printing newspapers in the world was 2.88 times 10 to the 7 tons. The world population was approximately 7.2 times 10 to the 9 people. Use this information to calculate the mass of paper per person. You know, there's no way we would do this without a calculator. This would be something we would, if we were asked to do it, we'd be using a calculator. In kilograms per person. So I need to change 2.88 into kilograms. There are 1,000 kilograms in a ton. So if I'm turning that into kilograms, rather than dividing by thousands like I was doing with the small things, I'm now going to multiply that . And 1,000 kilograms is going to be 1 times 10 to the 3 in standard form. 2.88 times 1 is 2.88. I can now add these to get 2.88 times 10 to the 10. That's what the mass is in kilograms. The world population was 7.2 times 10 to the 9 people. So I want to find out how much per person. So I need to do, God, that's how much paper was used by that many people. So I need to do 2.88 divided by 7.2. which is the same as, oh, I got brain dead again. Wait a minute. So that's the same as 2.88 over 7.2 times 10 to the 10 take away 9, which is 1. So I've got 2.88 over 7.2 times 10 to the power of 1. 2.88 times 10 is 28.8 over 7.2. That's the same as 288 divided by 72. How many times does 288 go into 72? If I double it, I get 144. It's going to go in 4 times. So it actually works out as 4 kilograms per person. There's going to be very, very few intermediate tier people getting anywhere near that. But we've completed the paper, okay?